Hi everyone. So we will solve today this beautiful problem from ISI MStat this year 2025. This is a random variable problem and rather actually unbiased estimator statistical inference problem, but it's a beautiful one. So let's understand. So you have random variables x1, x0, xn. These are independent Poisson random variables. And it asks you that how to find or whether there's an unbiased estimator of theta to the power m. So the very first step, so I've been trying to solve it myself. So I solved it till that point of time, and now I'm recording it for you so that I can share the ideas with you. So the first step always is this. The first step is always, um, sorry. The first step is always to write down what you are given. So you write down the mathematical expression of that. So you write down xi is Poisson theta, and then you write down the PMF of the Poisson here, right? So I've written down here, so probability of Poisson is equal to an integer value or whole number value is this. So now the next step, so after you're done with this, the next step is always finding or rewriting down what you know. So one important thing that we know is um, expectation of x bar is theta. How do we do that? So let's quickly go through the proof. Since each of the xi's are Poisson theta, the sum of the xi's is Poisson n theta. And if we divide by n, it turns out expectation of x bar is theta. Okay, so that's the basic idea. Because we know that if xi is Poisson, then expectation of xi is also theta. This is the known result, and we'll actually prove this result because this is needed. Now, once we are done with this, the next very important step is to think about what we know. Now, with what we know, it's not very obvious how to solve the problem, right? Because we need to understand, it's asked for theta is equal to m is equal to, in general, any m is equal to integer. Okay. Actually, m is greater than equal to 1, it's said. So whenever we are stuck in this scenario, the natural step, the most natural and simplest step is to form a simple problem. So instead of doing theta to the power m, we will do it for theta for 1, theta for 2. Sorry, m is equal to 1, m is equal to 2. So we will try to do m is equal to 2. Okay, and then we will not do it for all theta for all m values. Okay, what we will do, our whole idea is to do it for a few values and find, that is, solve that for the specific few values of m and try to find a pattern. Okay, and that's what your goal is, that's what your intention is. So we will try it for theta is equal to m is equal to 2, sorry, theta square, and theta cube m equal to 3, and then we will try to find a specific pattern. Also, one important thing is to note that we can also simplify in terms of the random variables. What if instead of xi, all the xi's, we just take one of them? So we can also simplify in terms of random variable. And we will see that why this is actually a special case where it can help us. And we'll see that towards the end. So watch it till the end. So let's write with clarity that what is the simple problem we need to solve. The simplest problem that I think is we can solve is this, that if x is Poisson theta, is there any function of x that is unbiased for theta squared? Okay, that's a simple way to write it, right? A simple problem we can solve. To do this, we will see that we need actually, so the proof concept of why expectation of x is equal to theta. So we'll just go through the proof idea. So the first step is writing down the meaning of expectation. So instead of writing the meaning of expectation, what I'm doing is that I'm writing the general form, expectation of x to the power k. We will see that why it's helpful. Or we can write expectation of x to the power m. And yeah, I have guessed it right. Yes, because it is related to theta to the power m. Okay, so we'll see that. So if we write expectation of x to the power m, you will see that it's I to the power m, lambda to the power m. Sorry, I did a mistake. Uh, yeah, I think, yeah, I to the power m. That's it. Okay. Similarly, so what we can do here, the basic first step is we will see, we can see that I and I factorial, the I of the I factorial and the I gets cancelled out. So we get this I to the power m minus 1 times uh, in below there is the denominator becomes I minus 1 factorial. And we will see this is the main equation that we need to solve, that we will refer to over and over again for solving this problem. So for I case, for m equal to 1 case, for m equal to 1 case, you can see that x to the this m minus m equal to 1, so this vanishes. Now we are left with this formula, and how we solve it? We usually solve it by, because we already know that sum of this PMF sum for all x is 1. So we will try to make it that form. The only thing this is not at that form is because of the lambda to the power I. So what we'll do is we'll take the lambda outside and it becomes this. And you can write lambda times summation of j from 0 to, where j is equal to, you define j is equal to I minus 1 and it becomes t to the power minus lambda to the power j by j factorial. And this is the PMF, so this is 1, sum is 1. So let's try it for m equal to 2. For m equal to 2, expectation of x square, we will try to do the same way. Okay, so sorry, I am calling it lambda, I don't know why. So because that's how I write it. So it will be, sorry if I've confused you, it will be theta instead of lambda. Okay. Yeah, it's a mess now, so let me rewrite it. It looks bad. So e to the power minus theta, theta to the power I, here to the power minus theta, theta to the power I, here also to the power minus theta, theta to the power I, to the power minus theta, theta to the power I minus 1, theta and theta to the power j. Very good. Not going to make this same mistake again. So e to the power minus theta, but there is, so it's x square, so there is I to the power square here. Okay, theta to the power I by I minus 1 factorial. Sorry, I factorial. I apologize. So how do we solve this? We again try to do the same way, but there's an extra I here. So what do we do about that? Theta to the power I, but here it becomes I minus 1 factorial. Now instead of 1, there is an extra I. So what we do? We try to divide it as this, right? It's natural. Like kind of make it I minus 1 plus 1. So I minus 1 plus 1 times this. So there'll be one portion for I minus 1 and one portion for I, 1. So I minus 1 times e to the power theta, theta by I minus 1 factorial, plus another portion for I equal to 1, where it will be 1 times e to the power theta minus theta, theta to the power 1 by I minus 1 factorial. And you can see here that again, this I minus 1 factorial get cancelled, and again for I equal to 1, it will not hold. So what we will do, we will start from I equal to 2, because it will cancel out. Okay, actually, it's not true. There'll be a theta common here, and then everything will cancel out. Yeah, theta to the power minus theta common here, and then everything will cancel out. Rather, it will start from j. Okay, I equal to 2. Okay, so let's not make it complicated. So what we can do here is that we can directly put I minus 1 equal to j, and we will get j from 0 to infinity, j e to the power minus theta, theta to the power j plus 1 by j factorial. So theta gets common here. And this turns out to be expectation of x, right? Got it, right? This turns out to be expectation of x. We have already solved it before. X to the power 1. Plus, here if you observe, it's again theta is common here. If you get theta common, you will see that it's e to the power minus theta, theta to the power I minus 1 by, and again you can make it j from 0 to infinity. And this turns out to be 1 because it's a PMF. But you can also write it as expectation of x to the power 0. So what do we get? We get theta times expectation of x to the power 1 plus expectation of x to the power 0. So it's interesting because it turns out something like this. Okay, but expectation of x to the power 0 is 1, and expectation of x to the power 1, we already know theta. So, and this turns out to be theta squared plus theta, which makes sense. And from here, we know that expectation of x squared minus theta squared, which is minus expectation of x whole squared, is theta, which is also variance of x. Okay, let's not deviate. I just wanted to show you, but the main equation is this also. This is the main motivation for the future. So the natural question is that, can we write? So this is why you start with a simpler equation, because as you go simpler, you find patterns. If you remember this, you find patterns. So this is the next natural question is that, can we find expectation of m is a similar function of its lower degrees. So let's try it for expectation of x cube, and we will get that summation of I from 0 to infinity I to the power 3 e to the power minus theta, theta to the power I by I factorial. So again, here I gets cancelled. You can start from I equal to 1. And you observe that it turns out to I square times the I gets cancelled e to the power minus theta, theta to the power I by I minus 1 factorial. So here you can again take theta common, and this will turn out to be this. So this part is screaming to you, can you write me? Is screaming to you, can you write me in terms of I minus 1? So what do we get here? We get theta. So yes, we can write, and here is the trick. You have written like I minus 1 plus 1, right? You have done it before. So now it's I square. How do you write it? Only in terms of I. It's simple. It's I minus 1 plus 1, that is I whole square. So you get I minus 1 whole square plus 2 times I minus 1 plus 1. This is how you write. So it's kind of binomial of the I minus 1. So you can write, sorry, I have taken this space out. So let me write it right here. Summation of I from 1 to theta, I minus 1 plus 1 whole square times e to the power minus theta, theta to the power I minus 1 by I minus 1 factorial. So this, let's rewrite this as, because this is not important anymore, you will see that, because you see that how we have found out this 2 here, right, in terms of expectation. So what we just need here is probability of x is equal to I, or we can write it as P of I. And you get that theta, you can write this as I minus 1 whole square plus twice I minus 1 plus 1 times Pi. Actually, it's Pi minus 1. So what we'll write it is write it as J. So theta times J from 0 to infinity, J square plus twice J plus 1 times Pj. Now you can see that yes, it's terms of theta times, you take J square Pj, summation of J square Pj plus summation of J Pj plus summation of Pj, Yj Pj. So it turns out yes, theta times its expectation of x square plus twice expectation of x plus expectation of x to the power 0. So this is what we got. Similarly, you can exactly do the same thing for expectation of x to the power m, which turns out to be summation of, if we remember, we will go exactly to till this point. Let me do it from scratch again. Helpful for you guys. X I to the power m, e to the power minus theta, theta to the power I by I factorial. So we rewrite it as I from 0 to infinity, one to infinity. So I to the power m, sorry, I to the power m minus 1, because I gets cancelled, e to the power minus theta, theta to the power, theta is common, so we write it as theta to the power I minus 1 by I minus 1 factorial. So as I said, this is screaming to be written in terms of I minus 1. So before that, we write it as summation of j from 0 to infinity, j plus 1 m to the power minus 1. And then we write it as e to the power minus theta, theta to the power j by j factorial. So it turns out to be theta times summation of j from 0 to infinity, j plus 1 whole to the power m minus 1 pj. And now this is a binomial theorem. So you get theta times j from 0 to infinity, and there's another binomial here. So it's, let's call it n from 0 to m minus 1. This is for the binomial now. So I'm expanding it. M minus 1, choose n, j to the power n times pj. So what we will now? So it's like I'm expanding this, just like I'm expanding it here. Okay. So now I will just take this summation outside. Okay, so imagine it's like this, m minus 1, choose, in case this is confusing you, j to the power n plus, sorry, 0, j to the power 0 plus m minus 1, choose 1, j to the power 1 plus dot 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 m minus 1, choose m minus 1, j to the power m minus 1. And then times pj. And now I'm taking the sum over each, like I'm multiplying it. Sorry. I'm multiplying it. So it turns out that this j to the power n pj turns out to be what? Because this is a constant, right? So this turns out to be what? Simple. Expectation of x to the power n. So expectation of x to the power m turns out to be summation of n from 0 to m minus 1 times theta, don't forget the theta, m minus 1 choose n, expectation of x to the power n. Just like we have seen it here. Okay. So there m is equal to 2, 3. Sorry, yes, 3. So this is the whole idea. So what does it mean? Simplifying, it means that if you rewrite it, let's write x to the power 0 is 1, x to the power 1 is theta, x to the power, like expectation of x to the power x square is theta square plus theta, expectation of x cube is, we have seen here, we have not seen here, yes, we have seen it here, so it will be theta times expectation of x square plus twice expectation of x plus 1, right? So similarly, so essentially what it means that expectation of, this is what theta m is a polynomial of degree theta to the power m, of degree m, polynomial in theta. So expectation of this is nothing but a polynomial of degree m in terms of theta. Okay, this is important. Now why does this help you? The reason it helps you is because this tells you that, so how is this related to unbiasedness? Because this will prove you that there exists a function of x that is unbiased for theta to the power m, because the highest degree here, you will always find the highest degree here. So for example, what is unbiased for theta squared? That was the problem we have not solved yet, right? This was the problem. It's simple. We know that expectation of x square is theta square plus theta. Expectation of x is theta. So expectation of x square minus expectation of x is equal to theta square. So expectation of x square minus x is theta square. So that corresponding the function of x here is this x square minus x. So expectation of f of that x is theta square now. Okay. Similarly, let's find for expectation of x cube. So if we add expectation of x cube here, so I have to find out for x's cube. For x's cube, we have seen this, right? M is equal to 3, so 2 choose 0. So 2 choose 2 times this, 2 choose 1 times this, yes. So this you know is theta square plus m. This you know is 2 theta plus 1. So you get theta square times theta square plus 3 theta plus 1 is theta cube plus 3 theta square plus theta. So you get right. So now it's interesting now. So you can now see that this is equal to theta cube plus 3 times. Now you replace the lower degrees as expectation. And that's what you have got here. Because you already know this f. So you have already found out that this f of x plus expectation of x, let's call it f2 of x. So what we are doing here, so essentially now we are doing induction, okay, mathematically. But essentially what we are saying is that there exists, we have found a like f1 of x such that expectation of f1 of x is equal to theta. Here f1 of x is nothing but x. Using this method, we have found out that expectation of f2 of x is theta square, where f2 of x is x square minus x. Now we know expectation of x cube we have found out is what, this theta cube plus 3 theta square plus theta. So what we're doing is that except the highest degree, we are replacing each of this, because we found out for each one of this f2 of x plus expectation of f1 of x, which each one of them are polynomials. So we have got, now take all the expectation on this side. So we have got x cube minus 3 times f2 of x minus f1 of x is nothing but theta cube. We are using the lineative expression. So this again tells you that this is f3 of x. So beautiful, right? So this, you can see we are getting this from here, this equation. This is the equation what we're using. So this is reverse. I hope you understand now this beautifully. So we are using this. Yes. So let me make you understand. So this is actually the whole idea of if you replace this, let me rewrite this. We have actually done it a longer way, like just to make you understand, but you can easily understand that no, we have actually not done a longer. We have so essentially you expand this, you get it to 3 degree, okay, and then you have to reduce it into 2 degrees. You lessen the degree, so you expand it to expectation of x to the power m as n plus dot dot dot, okay, right? There is something you have to do, and then what you do is that for whatever you will get here, theta to the power m plus a m minus 1 theta to the power m minus 1 plus dot, 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 you will get that. Replace each one of this with the corresponding expectation of f of m, this, which is unbiased estimator, which we know because we are doing it in an inductive manner, right? So this is where the idea of induction comes in. Okay, guys. So I hope you like this, and hope you like the whole solution. This is the whole solution of it. And this is how ideally you should have explained it. And like, you should not have done so many steps. You should have just first proved this one. This is the most important aspect. And then you explain it in this way. That's how you write the solution down. Ideally, like that's how the ideal solution should look like. So you should talk about this induction step. This is a very important aspect of proving it mathematically fully. This is how you write the proof, essentially. So I hope you like the solution. Feel free to subscribe, and I hope you enjoyed it. That's my only purpose. I hope you have believed or understood how to think step by step. And if you start thinking step by step, it's like the best. It's like now you are familiar with ChatGPT. You know, if you think in simpler manner, step by step, essentially prompting your mind with simpler ideas. Okay, and then naturally the whole solution blooms naturally. Okay, if you keep on prompting it. So that's the whole idea. So your brain is a big AI and use it to your advantage. So I'll see you in the next video. Thank you for tuning in. Bye bye. Have a beautiful day ahead.